Okay, great. Thanks for joining. So this talk will be kind of going over some of the concepts, both industry-wise and just conceptually around Cloud RAN. And you can kind of view it as sort of this overall transformation of the RAN or radio access network. And really it's a part of the larger network transformation that's sort of going on as we're heading from 5G and then long-term into 6G. So what I thought I'd do to start, there's a lot of terminology that gets used and sort of thrown around, and there's a lot of overlap, and some of the terms are used kind of loosely, and I kind of do the same sometimes. So I thought I'd just sort of level set a bit on some of the terms that you typically hear, what they're kind of referring to, and how they sort of relate to each other. So the first is what's called distributed RAN or DRAN. And this is sort of the typical legacy RAN deployment where you have a core and then your baseband and radio software are distributed throughout the network. So the RAN is sort of with the antennas or close to the antennas in a distributed fashion. Then CRAN or centralized RAN takes that baseband software and sort of consolidates it into sort of a baseband pool. Sometimes it's called a baseband hotel in a more centralized location. And it's connected over front hauls to the actual radios and the radio software. Then there's more the topic that we're talking about Cloud RAN, or sometimes it's called vRAN. And it's the idea of taking that baseband software and virtualizing it. And we'll go into a little bit what that means. But the idea is that you're putting that software onto kind of a cloud layer to get some additional benefits. Sometimes the term Cloud RAN also refers to this idea of a more centralized model, kind of like a data center model where you have the software there. And again, you have your radio hardware and software distributed. So the cloud term kind of comes from that general kind of like IT cloud concept where you have some centralized server somewhere with applications running that you access. So there's sort of that centralized model. The term is also used just to refer to the fact that it is virtualized in kind of that cloud way. So the term Cloud RAN sometimes gets used to mean different things. Sometimes it's referring to that centralized sort of pooled concept. And sometimes it's used to just refer to the fact that the RAN is virtualized. And sometimes you'll see virtualized RAN used in that term. So different companies use it in different ways and sort of interchangeably. For example, Samsung refers to their Cloud RAN as vRAN, and Ericsson calls it Cloud RAN, but they're essentially the same concept. And to make matters worse, sometimes you'll see CRAN referring to Cloud RAN, even though that term is also used to refer to centralized RAN. And then there's the concept of Open RAN, which is sort of defined by the O-RAN Alliance, which has tried to open up the interfaces and sort of standardize the different components and how they communicate into kind of this open model where you can plug and play different things together. So that open concept is really just trying to say that we're standardizing those interfaces, and now, in theory, different equipment from different vendors can kind of talk to each other. So as you can kind of see, for a particular deployment, different terms might be applicable. So you might have a case where I have virtualized or Cloud RAN, and I've centralized it. So it's a CRAN, and I might be using Open RAN equipment. So it might be O-RAN as well. So these different terms are just talking about different flavors. And again, there's sometimes a bit of ambiguity there, but in general, they sort of have their own connotation, and they kind of come together to describe the overall picture of a particular deployment. So if you've sort of been around wireless a little bit, no doubt you've heard of some of these organizations. So 3GPP is kind of the basic standardization body that covers cellular telecommunications. It covers radio access, core service capabilities, things like that. But it's sort of the de facto standards body that drives cellular wireless networks. Then there's ORAN, which was formed in 2018, and it's basically a community of mobile operators and vendors, and they're trying to change the industry from being kind of proprietary, single supplier, purpose-built, and disaggregating that to be more open with defined interfaces, being more intelligent, virtualize, all those kind of things. So it's sort of a collective group that is trying to transform the industry in certain ways, both to introduce more competition into the market, make some integration easier, take advantage of different technologies. So that's a group that's gained quite a bit of traction and has been going for a little while now. And then new on the scene is the AI RAN Alliance, which was formed last year. And the focus of that, same concept in that you have different companies from industry and academia coming together, basically with the idea of how can we integrate artificial intelligence into the RAN. So it's a new player that is getting a lot of attention at the moment and kind of driving a lot of the conversation in the industry. So a bit of kind of the overall evolution that is going on. So originally, RAN was very much a purpose-built, tightly integrated, and sometimes you hear the term bare metal, meaning sort of running directly integrated into the hardware. And that's the traditional model, and it's been optimized over decades to handle and efficiently process the wireless algorithms and so on. So that's been the model that's been around a long time. Then it started to shift to a more virtualized model, meaning I'm trying to disaggregate a bit the software from the hardware, and I might run that in virtual machines so that it has its own isolated environment to run in and can function independently, be deployed in different places, and so on. So it's dividing those overall resources that the system has into virtual machines that the individual functions can use. However, because there's a fair number of layers and abstraction, it's pretty heavyweight when you get into RAN, because RAN has a lot of real-time constraints, is always sort of under pressure to be processing fast enough, delivering higher performance, and so on. So this is a bit of a heavyweight model that isn't totally applicable. And that's led to a shift to what you could call containerization. So it's a more lightweight version of virtualization. And the idea here is that your functions can run in what's called containers, which is really just an entity that packages all the dependencies and, again, provides sort of a dedicated environment that can be deployed on different platforms, but it has everything it needs to be able to run. And there's usually a container engine that it will run on to help manage those entities, start them up, take them down, manage their life cycles. But again, it's a more lightweight model. So this is essentially what is used today. And the difference sort of from the virtual machine model is each of those containers is sort of using the full set of available resources. We're starting to see a shift more to a pure cloud native model. And again, the term cloud native is probably like overloaded and a bit vague at times, but I think generally you can take it to mean that it is systems that are developed from the ground up with the cloud sort of techniques and strategies and models in mind from the beginning. So the sort of issue that RAN has had is we've started from a particular form where everything was sort of tightly coupled, monolithic, and so on. And to pull that apart is challenging. So it kind of started with what I kind of called like RAN in a box, where we sort of took the existing RAN functions, put them in a container, for example, and ran them that way, but didn't really disaggregate them in a way that's sort of a true kind of cloud model. But we're starting to see more of that shift now. And how particular companies do that is sort of up to them. So that's kind of proprietary secret sauce, how they take this kind of monolithic RAN application and disaggregate that into a more microservices model. But this is the overall trend that's going on. So why do we want to go through all this sort of pain and suffering? So from a traditional RAN perspective, again, it was run on purpose-built dedicated hardware. It sort of had static network functions that were deployed in particular ways. The hardware and software were tightly coupled, meaning that the software knew all about the capabilities and specific details of the hardware it was running on to try and take advantage of it. And the hardware was designed in such a way to provide the capabilities that it knew were going to be leveraged by the software. So again, kind of very tightly integrated. The issue with that in part is that in RAN, there's kind of these long hardware refresh cycles. So probably typically 3 years to 5 years, you would get a new kind of hardware generation to come along, which is quite a long time by today's standards. Historically, lots of things were kind of like manually configured. Testing was manual. Deployment was manual in the sense of you're sending engineers out into the field to deploy the software, set up the equipment, all that kind of thing. Because of the tightly coupled nature, we had what's called large restart domains. So the idea of a restart domain is just that if you have some kind of fault in a part of the system, because of the fallout from that, you have to restart some component or aspect of that system. And in the case of RAN, you could have a case where you might have an issue processing a particular UE, for example, and that fails, and it could end up taking down the whole system just because of that failure and the fallout from that. And again, that's a result of the tightly coupled nature of the system. Additionally, because everything was sort of proprietary and purpose-built, all that expertise was kind of like internal to those RAN companies, and everything was sort of RAN expertise. And because of that, you're not taking advantage of the larger software and hardware ecosystem and tools and expertise that is out there. And then from an AI point of view, looking forward, part of the challenge that traditional model has is because it's so dedicated to RAN, it has a harder time opening up to all the possibilities that it seems like AI is going to provide. So there are ways to incorporate those things, and companies are doing that, but there are kind of limitations that come with it. So from a Cloud RAN perspective, what we kind of hope to get to address some of these things is that the concept of cloud is trying to do this disaggregation and separation of the hardware from the software, and is trying to use more generic hardware that isn't solely dedicated and built specifically for RAN. So from a purpose-built perspective, it's hoping to bring more capabilities and kind of be able to support a broader range of applications. Then from the static network function perspective, the cloud model allows you to more easily distribute and manage those functions. So you can more easily deploy them in a centralized mode or distributed mode, be able to scale things dynamically, give more resources to the system, create more instances of certain functions. We'll go into a bit more of that, but it adds some flexibility that we can take advantage of. And then from decoupling point of view, that shifting to a more modular microservices model enables a lot of things when it comes to things like continuous integration and continuous deployment. I'll go into some of that as well, but in short, basically that's just how do you develop the software, deploy more quickly, more frequently, and in a more automated way. Then from a refresh cycle point of view, because you're using more generic and often third-party hardware, you're able to take advantage of both the different suppliers. And we're seeing that those generic platforms are being refreshed much more frequently, like even up to every year. So those improvements are coming much more rapidly. And with Cloud RAN, where the software isn't quite so tied to a particular implementation of hardware, it's able to ingest and take advantage of those new platforms a bit more easily. And then sort of from a configuration and system testing point of view, again, so CI/CD, we'll review a bit that. GitOps, which is a way to kind of manage lifecycle aspects. It's a way to automate that deployment process. And by automating it, you're removing some of the kind of the manual aspects that can lead to mistakes. So the more manual that kind of deployment is, the more there's a chance that each time you run through those steps, you're going to make some kind of mistake. From a restart domain point of view, one of the advantages of kind of the traditional cloud microservices model is you have more encapsulated functions with clearly defined interfaces, and they tend to be smaller. So if there's a failure within one of those entities, it both limits the spillover effects into other entities, and also the cloud infrastructure is designed to detect that there's been a failure, restart that component of the system. So sort of taking advantage of that sort of robustness and recovery capabilities. Then from an expertise point of view, it's opening up kind of the RAN industry or the RAN space to take advantage of the larger cloud ecosystem, enterprise tools and techniques, open source, and basically a broader industry expertise can be brought in to help solve some of the challenges that we have. And then back to the AI point of view, generic hardware, the advantage of that is that we're going to be able to support a broader range of AI functionality in addition to the RAN. And also with that faster release cadence that AI is likely to have, that more generic and open hardware is going to be better able to support that. So again, there's lots of other reasons besides this, but to me, these are sort of the core ones of why are we looking at Cloud RAN? What do we want it to do? What does it bring to the table that's going to support some of our needs? So the shift. So sometimes you'll hear a discussion of the network is moving from a vertical model to a horizontal model. And really what that means is in the historic point of view, again, things were sort of vertically optimized. And by vertically, you can think of, I have my RAN software, I have my RAN operating system and my RAN hardware, and those are tightly integrated and optimized so that that RAN function works as well as it can. And it's very tightly coupled in that vertical stack. As a result of that, it's a very monolithic entity where all the components are very closely linked together. They're very dependent on each other. They know how each component functions and takes advantage of those individual things. But because of that, in part, it tends to be more static. So deployments, for example, are sort of configured with kind of like a worst case where I need a particular capacity in my network, so I have to dimension everything for that worst possible case. But because it's sort of vertically integrated, the RAN itself would be configured for that worst case. And the core would be configured for its worst case. And the radios would be configured for their worst case. But it's not really optimized from a network overall. So that has sort of caused this shift to the horizontal model. And the idea here is that you're breaking up that vertical stack and changing them into horizontal slices. So you can think of like your hardware layer at the bottom, and then there's what's called the CAS or containerization as a service, or kind of your cloud layer. And then your RAN software functions are sitting on top of that cloud layer. And then there's a management layer sitting on top, looking at the whole RAN and the network and all the configuration, what's going on, observability. And then now with AI coming, there's sort of this intent layer that's sitting on the top. So we'll go a little bit more into that. But the idea there is that as we're automating the network and we're bringing in AI to do some of that automation, it's making decisions and looking at the network overall and trying to optimize from an end-to-end perspective and not just as like a vertical individual function perspective. So it's shifting to more loosely coupled layers. It's becoming more functionally disaggregated from a layer point of view. And as a result, it's becoming more dynamic because I can tune and optimize each of these individual layers, again, with the goal that each of them are going to play their part for the overall performance of the system. So I have more ways to adjust and optimize for particular use cases at particular times based on capacity needs and so on. So sometimes you'll hear this term of shifting from vertical to horizontal, and that's really what this is referring to. So one of the main advantages of the cloud model and why it was looked at or started to be looked at from a RAN perspective coming from kind of the cloud IT enterprise world is these different concepts of scaling, pooling, and microservices. So scaling is referring to taking your individual components or functions and scaling them in different ways. So the concept of horizontal scaling is that I'm creating additional instances of a function to provide more capacity or computing power. So in the case of the RAN, I might have my CU-CP or CU control plane, CU user plane, and my DU. And there might be a case where I need more UP processing capacity, and I may create an additional instance while I need that extra capacity. And then once I don't need that capacity anymore, I can take that instance down. So I have some flexibility to increase and decrease the capacity that I have. And then the concept of vertical scaling is providing more compute resources to a particular instance. And typically that means more like CPU processing power or more memory. So the cloud platform can dynamically allocate and remove additional resources to those instances. So these two sort of strategies add a lot of flexibility to the system to dynamically adjust to the needs at a particular time. The concept of pooling is that I'm able to abstract a bit the hardware sort of compute resources I'm sitting on and be deployed across them in a more efficient way. So if each one of these is a particular server, in kind of the traditional model, I have a particular function and it's going to sit on a server, and I need individual servers or a set of servers to support those computational needs. The downside of that is that, again, I'm often dimensioning for the worst case. So I need a server big enough to deal with the worst case of what the system is going to need at a particular point in time. And the idea of pooling is that I can have a set of resources, but I can now consolidate my functions across those. So in the cases where I'm at a point in time where I don't need that much compute horsepower, I can consolidate those potentially on a lower number of servers, and maybe I can put another server in power save mode or things like that. So it's able to better optimize to what I need at a given point in time. And because of that, I'm able to get some savings, whether, again, like power saving or things like that. So this idea of pooling is just that I have a set of resources that I'm pulling together and I'm running my functions on top of that. And I'm better able to take advantage of just what I need at a given point in time. The idea of microservices, again, is, I'm disaggregating my RAN into smaller components. And the smaller I can make those units, the more granularity I have to tune them via these different methods. So when Cloud RAN kind of started out, and in most cases it tends to be like this today, they're still relatively monolithic in that I may have, a DU function, a CU function, and so on. And yes, I can scale those horizontally or vertically, but usually with RAN, different aspects of the system scale in different ways. So some parts might scale because of the number of UEs connected. Other parts might scale because of the number of cells I have, and so on. Where if I just say give additional resources to the system overall, they might not be directly utilized by the part of the system that needs them most, and other parts just take advantage of them because we're there. So if you can architect your system to better align to how different parts of the system scale, then I'm better able to use these techniques to kind of optimize. So that's sort of where the microservices idea comes in, where if I can disaggregate into smaller pieces, I can now scale them differently, deploy them in different ways. I have more flexibility. So automated and programmable. So one of the big topics going on right now in the wireless in RAN space is moving to more automated networks, and you're starting to hear the term programmable. So really what that means is, again, we've kind of been shifting more to this horizontal model, and it's trying to automate the network such that it, again, tunes itself to a particular goal. And the idea of programmable is that I'm able to give the system instructions of what I want it to do, and it's going to go and carry that out. So one of the new terms that's sort of come along the past year or two, I guess, is this idea of intent. And what that is saying is, I want some entity or set of entities that sits at the top, and I want to be able to tell the network, I want to achieve some goal. I want to provide a certain service to some users. I want to optimize for power saving, but I'm generally giving it sort of a more general instruction of what I want the network to do. And then that intent layer is going to figure out, how do I take that sort of generic instruction and convert that into configuration parameters and so on, such that I can tune the different layers of the network to optimize and achieve the intent that I've been given. And I want to do that in an automated and dynamic way. Because the challenge that we have is that the network is becoming so complex that it's getting to the point where it's not really feasible to do that manually, to go and figure out exactly what I have to tune all my parameters to for all my different layers and constantly update those all the time. So we're handing that over more to AI to figure out how to do that translation, to make it easier to operate the network, where the telcos and the operators don't have to understand what every little parameter means and how to tune it and all that kind of stuff. We want to add an abstraction layer there that is going to handle that complexity for us. So again, it's moving to a much more automated model. And this idea of programmable is that I'm going to be able to give it instructions, and the network sort of carries that out. So there's sort of a loop that happens, that intent layer at the top is looking at all the observability of the system. So whether that's coming from hardware, temperature, utilization, all that kind of thing, the containerization layer, how much compute resources are being used, what failures there are, all that kind of thing. RAN function, what is my throughput, KPIs, all those sorts of things. Those all get fed to the management layer, and that is given to the intent layer. So it's looking at the system and various aspects across the network. It figures out, based on my intents that I have and what I'm trying to achieve, figure out what do I want each of these layers to do. And so there's a control aspect where that instructions get sent down to the different parts of the layer to optimize to that whole. So when you put all that together, you can imagine a case where, for some period of time, say over the course of a day, early in the morning, maybe the network's slightly used. And so I only have a few functions that need to run because that's going to support the capacity that I have in the system at the time. As the day goes on, that more people are using the network. And so I may scale up particular entities or scale out. So I might create more functions to handle the new load. And as time goes on, I might give those functions more resources. Then maybe there's a dip, so I can scale back a bit, I can scale up. And at the end of the day, when the network load drops, I might scale in some of those entities again. But the intent and management layer is constantly looking at what is happening within the network and seeing how does this align with what I'm trying to achieve and what adjustments do I need to make as I go. So the idea is to shift to this model where it is constantly updating and optimizing all the time. And that's moving from the traditional model of, again, kind of worst case provisioning and kind of one size fits all, where you're setting your configuration parameters to something that is good enough for most of the cases that you're going to have to face. And to do that, you're seeing more discussion about apps and APIs. So the topic of network APIs is very big at the moment, and the idea of apps sitting on top. So that intent layer is kind of using this apps and APIs model. So the idea is that, you know, we have sort of a management layer, and I have some API platform, and that intent layer is a set of apps that sits on top of that and uses that interface to talk to the network. Then there's another type of platform that is more closely tied to, say, a particular G node B, and it can talk to CU or DU, and it is looking at optimizing that particular G node B. And now there's been more discussion of even more tightly integrating applications, say, into the CU and DU directly. In an ORAN model, if you've seen that picture before, there's the concepts of the RICs. So I have my CU, CUCP, CUUP, and DU and RU. So that's kind of the traditional G node B. Then there's the non-real-time RIC and the real-time RIC. So the non-real-time RIC sits up in the what's called the SMO, or the Service Management and Orchestration Framework, which is, you can sort of picture as kind of the network management layer. And it provides an interface to what are called R apps. And R apps are generally looking at timelines that are like greater than a second. So it's more of a slow loop. Then closer to the G node B is the near real-time RIC, and it's operating on time sort of greater than 10 milliseconds or so. And ORAN defines different interfaces to support that. So from a near real-time RIC perspective, there's the R1 interface, and the non-real-time RIC, and the near real-time RIC has the E2 interface for what are called X apps. So again, it's running on a faster timeline. There's been some discussion and proposals about another type of app called a D app and a new interface called E3, and it's intended to be more tightly coupled with the DU and sort of operating on kind of the 1 millisecond or slot timeline. But there's been a few kind of proof of concepts for that, but it's largely theoretical at this point, where the non-real-time RIC and near real-time RIC, R apps and X apps, is much more standardized. R apps are by far the most common at the moment, and it pretty much dominates the discussion today. X apps, there's a bit of debate with different companies. Some companies feel like it's not really, it's really just the RAN function that's going to do whatever the X app provides, and don't really think there's a need to have this kind of separate interface and separate application. Other companies are looking at doing this, but so R apps are probably here to stay. X apps maybe a bit more open debate, and whether D apps come along, hard to say. So this is the general model, and this is kind of the ORAN version of that. Okay, CI/CD, or continuous integration, continuous delivery. So this is kind of a busy slide, so see if we can make sense of it. So the general CI/CD model, this is used all over the industry and is pretty much kind of the de facto software development model these days. The idea is that, you know, you're going to code, you're going to build that, you're going to test it, you're going to release that to the customer, they're going to deploy it, they're going to operate it, you're going to see how it functions, you're going to take that feedback, and you're going to make adjustments. So it's that continuous cycle of sort of develop, test, deploy, observe, around and round and round. In order to deliver that internally, the way that's kind of implemented is sometimes you hear the term CI/CD pipeline and things like that. So the idea is that in the Git world, you have your application repos, which is really just software, what's called software tracks. So I'm making deliveries to my product and updates over and over and over again. When I make an update to that track of product, it's going to trigger some infrastructure to do integration. So I'm going to pull in all the components for that product. I'm going to test that. If that test is successful, then I'm going to store that as a working version of the software. Additionally, there's the idea of infrastructure as code and configuration as code. Really, all that means is that all the configuration and any kind of infrastructure that goes with that product to support it is also implemented from a code point of view and uses the same idea, where if I make a change, for example, to the configuration, that is also going to trigger pulling all the components together, running it, making sure that that update to the configuration works, and that's stored as a single entity. So from the CI point of view, that's the idea, is that I make an update, whether it's to the product code or configuration or infrastructure. I'm going to automate the testing of that to bring those components together, run it, make sure I'm happy, and then I'm going to store that as a new working version. So that's kind of on the internal side. Then when we get to the external side, that is going to push those changes. It's going to get that latest version of the software and deploy that. In reality, usually what happens is, say a company like Huawei or Ericsson, they're going to have their internal labs where that newest version is going to be put into that bigger lab. Again, more testing to make sure everything's good. And eventually that's going to go to the customer. And usually the customer has their own labs and kind of test sites where the new version of software gets deployed, it's checked, and when they're happy with it, they'll roll that out to the rest of their network. So there can be multiple stages to this deployment, but the general idea is that I'm constantly sending updates to the system that they can incorporate. And that has sort of affected how software is sort of developed. And sometimes you hear the term, the old school waterfall model to the more agile CI/CD model. So the old way, the idea was I might have a particular feature. It may touch multiple domains, say layer 1, layer 2, layer 3. Each of those groups is going to go off, do their portion of the code. And then when everybody's done, we're going to put it together. We're going to integrate it. And then we're going to test it. And if we're lucky, we make the scheduled release timeline. And sometimes we don't. So there was a lot of late nights and frustration trying to get things to work to try and hit a particular deadline. And because of this model, the releases were very infrequent, usually no more than twice a year. So it meant that missing a deadline was a big deal because then the customer had a long time to wait and they would get upset. So this new CI/CD model, what it's trying to do is integrate things much more quickly. And also you would often, instead of trying to do the full feature before you do any integration, is you figure out, what is my minimum viable product that I can build and integrate first. So I would sort of have sequential parts of the overall feature such that I could integrate them and test them early and deliver them more frequently to the customer. So often now the release timelines are maybe more like 3 months or even 2 months. And in theory, the customers could get releases, every few weeks or something like that. But the idea is that I'm going to have smaller pieces that are integrated and deliver those more frequently. And this is supported by the fact that I'm able to automate and deploy in an automated way a lot of my testing. So that's kind of the idea of CI/CD. And this is, again, largely become the de facto way software and deployment's being done today. So from an industry point of view and Cloud RAN, we are starting to see a fairly significant shift in this direction. So initially there was, quite a bit of skepticism on how this was actually going to work and how efficient it was going to be, and were we going to be able to meet sort of the requirements. But now there's been lots of more sort of public commitments and discussion about moving in that model. So AT&T, for example, they're looking at maybe 70% of their sites shifting to Cloud RAN, and they're saying 2027 is probably the point when they really start to shift pretty heavily. Verizon has about 23,000 Cloud RAN sites today, and they have those in high density centers, Manhattan, things like that. And they've said that they're planning 100% transition to Cloud RAN. Vodafone in the UK, they're seeing a significant shift, and in Europe overall, they're expecting about 30% Cloud RAN sites by 2030. Telefonica, at least 20% of their sites by 2020, starting in 2025. Deutsche Telekom, 3,000 sites by the end of 2027. Orange, they're saying that basically any new equipment is sort of shifting to kind of the Open RAN, Cloud RAN type equipment. NTT Docomo, they're targeting about 10,000 sites. And then TELUS, interestingly, they're also saying they're shifting to 100% a Cloud RAN. All their new deployments today are, from here on out, are 100% Cloud RAN. They're expecting about half of their sites by 2027 to be Cloud RAN, and by 2029, they're expecting 100% shift. So TELUS is actually quite far ahead and are one of the leaders in the world shifting to kind of this Cloud RAN, Open RAN model. So various kind of industry groups, they're sort of predicting 25-30% of RAN deployments will be Cloud RAN kind of by that 2029 timeframe. And they're seeing basically a steady shift to that more kind of open, virtualized, automated type networks. So some of the challenges that we've had. Again, like from a complexity point of view, like RAN is very complex, and there's very strict real-time requirements when it comes to scheduling and all the things that need to happen over the air. So cloudifying that, meaning kind of disaggregating it, putting more layers between the software and the hardware, pulling those units apart to be more in a microservice type way, that is very challenging. So trying to make algorithms that have been developed over decades and had this assumption of kind of a monolithic tightly coupled model is difficult. And the farther you go down the RAN stack, so like layer 3 with your CU and your DU with like layer 2 and layer 1 and your RU, the farther down you go, the harder it becomes, because those tone lines just get faster and faster and faster. Then there's this idea of like worlds colliding. So like when I started, RAN was very much, again, like single purpose, one particular company who did everything. They did the hardware, they did the software, and there was decades long strategies of how you just did certain things. Then this kind of cloud world comes along, and we don't really know anything about it. And so trying to ramp up and understand all these cloud techniques, the assumptions, that's very difficult. And vice versa from a cloud side, they don't come from that RAN background. So trying to adjust and accommodate each of those entities is difficult and takes a while to get on the same page. And now with AI coming, it's the same thing. It's a whole new world for us to learn and try to figure out how to incorporate and the pros and cons, what it's good at, what it's not good at, how to get around certain challenges. So that's been a big hurdle as well. Then from a partnership perspective, again, when you're doing everything internally, there's lots of advantage to that. And RAN is hard even then. Like there's been lots of times I remember, I was a layer 2 guy pointing our fingers at the radio guy saying something isn't working, and they're pointing their fingers at you and you're trying to figure out what's going on. That is hard enough even within one company. Now that we're bringing multiple companies together, that is much more difficult because companies have their own agendas and they don't necessarily want to share all the information about what's going on and things like that. So to try and integrate all this stuff and to get it to work and to optimize it, that is very challenging when it comes to this kind of partnership model. So it really changes how companies work together and how tightly they have to work together. So that's been kind of a long time coming. And takes a while to get there, build up your trust, understand what the other side, what their challenges are, and so on. And then from a feature set point of view, this has been, I would argue, been the biggest hurdle that kind of like the Cloud RAN, Open RAN model has. And that's the telco companies, they kind of want their cake and eat it too. They like the idea of Cloud RAN. They like the idea of I can use, a wider range of hardware. I can get my equipment from different vendors, all those great things. But I want the performance and features and all the benefit that I got from my traditional RAN equipment. So that makes it really hard to get new products out there because you're trying to catch up with equipment that is kind of a decade's worth of maturity. And that is the case both with new companies trying to get in, like trying to compete with, say, an Ericsson or a Huawei that has decades of experience and product development and that kind of thing. That's a huge challenge for new companies. But even within the existing companies, trying to come with a new product that matches their existing product, it's almost like they're competing against themselves. So it's starting to get there now, but that's been a long time coming too, and has been a real kind of like drag on that adoption process. So I thought I'd just touch a little bit to try and give a sense of some of the complexity that we sort of face. So from a layer 2 perspective, you can think of just a generic CPU where I have a bunch of tasks that I want to run. I have a certain number of cores, and they are just going to be picked up and operated on when those cores become available. The challenge with that is that I don't always have a lot of control over when a process is picked up, when it starts, when it finishes, when the next one's going to start. And from a layer 2 perspective, we're trying to schedule on these very specific slot boundaries, whether it's 1 millisecond, half a millisecond, and so on. So trying to operate on a generic platform that isn't dedicated to that kind of specific timeline scheduling processing is a challenge because RAN needs to know, or layer 2 needs to know, I need to start my processing exactly at a specific time because I have to get all that work done so I can start on the next slot. And I need to give layer 1 my results so it can go and do its work so I can get it to the radio, et cetera. So shifting to the cloud model, there's once you get into the details, it can get very complex because it's kind of a different model and has different requirements. From a layer 1 point of view, it comes with its own challenges as well. So the downside of hardware that isn't dedicated is that it doesn't lend itself particularly well to layer 1 processing, which is kind of very parallelized by nature. So because of that, there's this concept of hardware acceleration to accelerate particular parts of layer 1 functionality. And there's an industry debate at the moment about what is the right model to do this. So the first model is called inline, and the idea is you take all of layer 1 and you stick it on one of these hardware parallel accelerators. The other model is look aside. And the idea there is that I'm running probably most of my layer one on the CPU, but for certain functions that really do lend themselves to a lot of this sort of parallelism, I'm going to send those over to the hardware accelerator, run those, get the result back, go to my next step in the chain. And I might be sending a few of these particular functions over to layer one. Each of them has their pros and cons. Different companies have their preferences. They each make their claims of why a particular way is better, but there hasn't really been a consensus at this point of what's the right way to go. So that's still going to play itself out a bit, but those are kind of the two main ones that you'll see discussed. But again, in general, really the point I'm trying to make here is that once you get down into those lower layers of RAN, the processing becomes very challenging in terms of the timelines you're trying to meet and the specifics of it. So moving to that cloud model is a challenge. So some of the current challenges, again, the microservitization where you're trying to pull these things apart, very difficult to do. Market dynamics also plays a major factor. So Open RAN and Cloud RAN have what I call the chicken and egg problem. And the idea is that you have these telcos that say, okay, great, I want all this new Cloud RAN equipment. And you have these suppliers that want to jump into that market. But everyone's kind of been waiting and seeing to say who's going to make that investment. So if I'm, say, a supplier, I want to know that there's going to be investment there at the other end. And the telcos are saying, well, I don't really want to pay all this money if I don't know that that product is going to be there at the end. And the telcos, like say AT&T versus Verizon, T-Mobile, Bell, they're all kind of hoping that I'm hoping somebody else makes all that investment, and then I'm just going to get that mature product at the end. So everyone's kind of waiting and seeing who's going to do that. You're starting to see those dominoes fall again, based on some of the roadmaps that they're talking about now. But for a long time, there was sort of this wait and see type mentality that was slowing things down. From an organization point of view, Cloud RAN and like CI/CD, all these kind of things, they just bring so many fundamental changes in technology, how things are done, how your hardware is sourced, how you develop your software. So it's a real impact on the organization overall. And even though the technology challenges are pretty large, often the people challenges are even larger in terms of actually getting something out the door and maturing that technology. So this has been a major factor as well. And then there's the perception of, I'm coming from something that it was developed and integrated and dedicated specifically for this kind of RAN purpose and optimized for that. So how can, taking the hardware that isn't as dedicated to RAN, adding these different layers to it, how can I meet the performance that I get with that traditional model? So for a long time, there's sort of this skepticism of, okay, maybe we can do demos or that kind of thing. How is this going to perform in the real world, in the real network, and so on? So now that we're starting to see some of those deployments and that they're able to meet those KPIs, that perception is changing. But for a long time, there was sort of that skepticism of how well this was really going to work. Then just a little bit on AI RAN. Again, the hottest topic by far. You won't go to any conference that doesn't talk about AI RAN and how we're going to apply all this stuff. And there's a few particular models when it comes to RAN of how AI is expected to play a part. And you may have heard a bunch of these terms already. There's AI and RAN. And really that just means I have AI and RAN on the same infrastructure. So I have some RAN functions, I have AI functions. I'm going to run on this sort of cloud RAN model where they're running in containers on some generic hardware. And basically, it's just trying to share those resources to do these different workloads. And they're not necessarily working together, they're just taking advantage of that infrastructure. And that has brought along a proposal about whether we should use GPUs to do this acceleration. So in the AI world, GPUs are very commonplace and used everywhere. That is not the case in AI or in traditional RAN. So whether we can use those GPUs to say do some of the layer one acceleration while also supporting AI workloads, that kind of remains to be seen, and some of the debate going on. GPUs are typically very expensive. They're power hungry, things that are kind of antithetical to what RAND wants, but we'll have to see if the financials work out. Then there's AI on RAN, meaning the RAN is sort of being optimized and used to provide AI sort of functionality sitting on top. So really it's just another application that would be using that wireless interface and having RAN sort of optimizing for those particular use cases. And then there's AI for RAN, meaning taking AI and using it to improve the performance of the RAN itself. And whether that's AI that's sort of integrated into the RAN functions themselves, whether it's additional workloads that are working together with the RAN functions, that sort of remains to be seen at this point. But again, those are all running on this sort of cloud platform. So Cloud RAN is really becoming sort of the assumed platform of AI RAN and all the AI discussion that's going on in the RAN space at the moment. And as one example, so SoftBank is a big player in kind of this AI RAN Alliance organization, and they're doing a lot of work about what is the right applications? How should it look? How's it going to function? How do you coordinate these things? But as you can see, it's sort of a familiar picture. I have some kind of hardware platform, I have virtualization, I have a RAN function, I have an AI function there. So that model is kind of the de facto proposed model. So they're kind of aligning to this kind of picture. So some of the future challenges. One of the biggest ones is the monetization. So what you hear in kind of the RAN world is, okay, there's all this discussion about AI and how great it's going to be and all these problems that it's going to solve. What is actually going to make money? And that is the big question at the moment, is that sure, you can do some of these things, but how is that going to work from a business point of view? How is that going to support, if we decide to use GPUs, how do you make that financially viable? What are the revenue streams? What are the use cases that are going to do that? And 5G was something that telcos sort of felt like they didn't really get a great return on investment. And so they've shifted from the old way, which used to be kind of this fear of missing out, where, well, I have to deploy, the next generation of, 3G, 4G, 5G, so that I can take advantage of it. I got to get it out. So there was always this rush to do that. After 5G, they've been taking more of this, I'm going to wait and see. Like, I want to see that there's actually money going to be made before I do this cutover. So that's a big thing, and especially coming with AI again as well. What is the money? Where does it come from? What are the financials? Then there's the supplier ecosystem. As Cloud RAN is becoming mainstream and O-RAN is becoming more mainstream, because of the chicken egg investment, there's a lot of companies that are struggling financially. So it's hard for other companies to invest because they don't want a case where their supplier kind of disappears on them and so on. So that supplier ecosystem fluctuates a bit, and how that's all going to play out sort of remains to be seen. And again, so the AI use cases, we are in the very peak of the AI RAN hype cycle, I would say. What are the benefits? Are they real? And the RAN industry is sort of worried about being what they call a dumb pipe that AI sits on top of. We're trying to figure out, how do we take advantage of this AI gold rush and actually make money ourselves? And then from an AI RAN deployment point of view, how does that actually look? Where do these AI functions need to live? Can they all live in data centers? Are they mostly going to live on handheld devices? What actually has to be on the RAN? Should it be separate entities? Should they be integrated? All that is kind of TBD. So until we know more about the use cases, so that we can know more about where those functions need to live and what the infrastructure is needed and so on, that's kind of all TBD and needs to be figured out still. So if I was to have a crystal ball, this would be my guess. I think in general, these trends are going to continue. The more we see talk about 6G and AI, it is really baking in that assumption of kind of a cloud RAN platform that it's going to sit on. As we're seeing with some of the telco announcements, excuse me, cloud RAN is continuing to eat into the overall sort of RAN market share. The performance will continue to improve. We're seeing lots of improvements with, say, the cloud layer providers. Everybody's getting better at how do you optimize these things, how do you integrate them, what the hardware needs to look like, all that kind of thing. So I think you'll see it'll generally converge to the purpose built. I think despite the uncertainty, AI is going to find a home in the RAN architecture, I think. As the hardware gets cheaper and better support, and the use cases become clearer, I suspect there's going to be applications that do make sense to live on the RAN. The software is going to continue to shift to more of this microservices model. I think 6G is going to enable that a bit more. Part of the problem with 5G is was designed and developed in a way without really accounting for that, making it harder to pull apart after the fact. I think 6G is going to accommodate this a bit more out of the gate, which will make that transition easier. And because of that, you're going to see RAN functions that start to develop their own life cycles as these individual components are going to be more sort of isolated. You can update them independently and so on. So I think you're going to see that shift instead of having to kind of do these monolithic upgrades. And I think 2027 into 2028 is probably where you're going to see a lot of that acceleration. So I think the 6G, what that's going to look like, its use cases, that's going to be clearer as we get closer to 2030. AI is continually evolved, and I think those use cases will become sort of clearer over the next few years. Cloud RAN will continue to mature. It'll be deployed more. How to optimize it, real world, how to do things is going to be better. The suppliers are going to be more mature at that point. And what suppliers are going to be there and available, that will also be more clear at that point. So I sort of expect that time frame is when you'll start to see this really start to take off. Okay, that's pretty much what I had. I know that was a bit of a whirlwind, but hopefully there were some useful things in there. I don't know if we still have time for questions. I have a bit of time if we want to stick around. I think I've run a little bit over.